He's done. All right. I handed out a sheet to everybody. We are going to do 4 of these together before you start. Okay. We're going to do numbers 2, 4, 5, and 12. So you get like a wide range of how sort of all of these are going to look. So if everybody can just turn their heads up here, pay attention. We're going to go over some stuff. Now, yesterday we learned that if you have a function, the c is the constant, the n is a constant. How you take the derivative is you bring the n down, multiply it by the c, have it by the t, and then it's n minus 1. So the first thing we're going to look at is how we deal with when we have a fraction, and then we're going to look at how we deal with when we have a root, okay? So number 2 has a fraction, okay? You're given y equals 1 over x to the 5. So it says that would be written as x to the negative n. What that means is that we are going to have that y equals x to the negative 5. This is the exact same thing as that. And you guys have learned that in math, right? Okay. So when we take the derivative of this, one of the ways you might see people write the derivative, yesterday, we had the du over dt or the d over t or whatever. Another way you'll see people write it is with this little apostrophe, okay? So like a y apostrophe is a way that we're saying that we're taking the first derivative of this, all right? And when we do that, we still bring down, remember this would be like our n, right? We're going to bring it down in front, so we're going to have negative 5x, and then we're going to have negative 5 minus 1, because it's n minus 1, right? Okay, so that becomes negative 5x to the what? To the negative 6. So if we were to officially rewrite this, we're going to have negative 5 over x to the 6. So the power rule still works the same way when we have a fraction. You just have to rewrite it in this form first. And then remember that when we have a negative exponent, that it ends up going down to the bottom to be positive. So this rule right here is one that we should have already seen in math, right? Okay. So this one's not horrible, but then we've got this one. We have a root. So this is a 5 root, or a root 5, okay? And the way that we're going to be rewriting that is f of x equals x to the 1/5. Like we see over here, you change it to x to the 1 over n. Okay. And then, once again, one of the ways that you'll see people saying that it's a derivative is with that little apostrophe. And once we do this, we can keep carrying it out like we usually would. So we would bring down that 1 over 5 over here and have x to the 1 over 5 minus 1. And remember, if we've got 5 on the bottom, isn't 5 over 5 the same thing as 1 here? To make your fractions a little bit easier for you to do? Yeah? All right. So then we end up with 1 over 5x to the what? What's that 1 over 5 minus the 5 over 5 going to become? Negative 4 over 5. So that means our final answer here would be 1 over 5x to the 4/5. And I'm going to tell you guys right now that when we're doing physics problems, you hardly ever see stuff like this. It's usually going to be like this one right here that we're about to do together, okay? So honestly, when you're given, and especially on the AP exam, I've never really known them to do any weird like fractions or roots. I just like to show how to do them just in case. You never know. But it's usually just going to be like this, okay? So let's walk through this one together. So we get to jump straight to taking the derivative here because is there anything weird going on with them? Are they fractions, roots, anything like that? No, okay. But you remember yesterday we said you basically have to do it one by one, right? So first we would take the derivative of this one, then the derivative of this one, then the derivative of this one all separately. So we've got negative 2t squared. So how would we take the derivative of that? What would we do? We're going to have 2 times negative 2 t to the 2 minus 1, which is 1. So it's going to stay like that. Plus, what would we bring down from here? 1 times 3. And what's 1 minus 1? So what would happen to the t? It wouldn't be there. And then plus, is there anything to do with the 6? No. So what do you guys think happens when we just have a constant like that, when we take the derivative? It just goes away. It's like you're adding a 0. Okay? So basically a constant just becomes a 0 while we're taking the derivative because it doesn't have anything going for it. So we would end up with the derivative is, what's 2 times negative 2? Negative 4t plus 3. And like I said, there's one more I want to do with you guys on the back. It's number 12. That's the next most scary looking one in my opinion. Or would you guys? Yeah, no, 12 is the most scary looking. That's more scary looking than number 11. Okay. So I'm going to erase this over here just so I can put 12 up here. And then I'm going to leave them all up here while you guys are doing them. Because these are honestly the 4 hardest ones on the sheet, which is why I wanted to do them with you guys. Okay. So let's look at number 12. Okay. So this one says f of x is equal to 2x to the 4th minus x over x cubed. So how are we going to rewrite this before we take the derivative? What's the thing we have to change? What do we have to do with this right here, the bottom part? Yeah, so we're going to have 2x to the 4th minus x times x to the negative 3. Okay, so we move it on up. Then the next thing we can do to make our life easier is we can go ahead and distribute it. So what is 2x to the 4th times x to the negative 3? It's just 2x. Yeah. Yep, you add exponents when you multiply. When you multiply, you add exponents. So knowing that, what is going to be x times x to the negative 3? Yeah, we're going to have, so we have 2x minus x to the negative 2 now. And from this, we can now take our derivative. Okay. So what's going to be the derivative of 2x? 2. Okay. So we're going to have 2 minus, and then for this derivative, I'll sort of put it off like it's its own thing. We're going to remember, bring that negative 2 down, x, and it'll be negative 2 minus 1, which is negative 3. So that means that the final form here is going to be 2. What happens to these two negatives? What do they do to each other? Makes a positive over 2x cubed. Okay, so I'm going to put those sort of like rules up here again for you guys underneath this so you can have them while you're working on this. One other thing though, we will talk about tangent lines later. I don't want you to worry about those right now. So where it says finding the equation of a tangent line, so everything after number 14, don't worry about 15 and 16 right now, okay? That's fine because you already looked at how to do it. And I do have more practice if you guys end up wanting more practice. I printed off additional sheets, but just try and get through these first and see if you have any questions while you're working through them, okay? Because I know derivatives are new to everybody else. You can work with somebody. Yeah, of course. The only times I tell you not to work with people are quizzes and tests. Mm-hmm.
The dot notation.
Huh? Yeah. And while you guys are working, I'll come around and pass out the other practice sheets. They are optional. You do not have to do them, but it will be nice if you want to get more practice in.